Good evening. I'm Tom Conrad, the Superintendent of Schools for the Nauset School District, and welcome to Superintendent Spotlight, a half-hour show focused on programs and people in our system. So tonight's show is one that I've been waiting to do for a long time. And so let me tell you what we're going to be working on tonight, and I have a number of guests that you'll meet here in a few minutes. And it has to do with the autonomous car project. And as we finished the school year last year, Mr. Romer, who's back here tonight, and I did a show relative to what we thought was going to be happening with this autonomous car. And so I'm going to detail a few things about the program as it took place over the summer, and then we're going to get into meeting and talking about the experience. So as we finished the school year, within just days of summer break, we had signed up for the autonomous car project through MIT, and we were now trying to find students who would volunteer to participate in the program. And when it was all said and done, we were fortunate to find 8 great students, and 2 of which we'll meet here in a second. And they were committing to at least 30 to 40 hours of class time in the summer, all the way up till the weekend of August 6th, and doing homework outside the classroom experience to learn materials to be able to participate in this project. Mr. Romer, along with Mr. Tarkanian, spearheaded this effort, and through their volunteering all the time to make this happen, I'm pleased to tell you that we did make it to the race, and on August 6th, and we'll talk about that as well as we go forward. So the autonomous car is part of a project at MIT for the past, I believe, 10 years. And we are one of the few, if any, public schools in the country who have partnered with MIT to work on this project. So I'm going to introduce Mr. Romer at this time. Ed, great to have you back.
Hey, thank you.
And why don't you begin to tell us a little bit about this journey?
Sure. This journey culminated a long relationship that Superintendent Conrad and I had starting when he was principal to figure out ways to introduce, expand opportunities for high-quality, real-world STEM projects. And in June, we took a ride up to MIT to see some folks I've become friends with over the years that have helped me to get to where I am in some of my endeavors. And really, what the goal of this project was to expand access to project-based collaborative educational opportunities for the staff and students and community at Nauset. This race car project has been going on for a couple of years, and essentially what it is it's a culmination of an undergraduate course and research in the Aero-Astro Lab at MIT in autonomous vehicle systems and computer vision that has been condensed into, with the help of MIT School of Engineering and Lincoln Labs, to create a high school curriculum for a summer institute. And kind of with that, I'd like to maybe introduce Gabby Messier and Anthony Grandel, who participated in the project, to talk about this. And before I do want to express gratitude to MIT, to Beaverworks, to the undergraduate students that helped put this on, and instruction, and all the folks that helped make this happen. So thank you.
So, Gabby, we'll start with you. So what did you think of that experience? And there's no question it was grueling, I'm sure, at times. So why don't you talk about your thoughts?
So you definitely had to put in a lot of effort, and it helps if you enjoy engineering and coding, which I do, and everybody in the team did. So it was a pretty positive experience for me, and I learned a lot when I was participating in it, and it was fun too.
And were you surprised, at how quick this took place, and all of a sudden you had to change, I would think, your summer plans to some degree because of the commitment to this? Yeah,
it took a lot of re-coordinating events that I had planned in the summer, and but it was doable.
So you made it happen.
Yeah.
Yeah. Anthony?
Yeah, as Gabby said, it was a really great opportunity to learn all these skills that I'd always wanted to learn. And it was a big challenge, but we were able to overcome the challenges we came to, and make a working race car.
So let's talk about the race car, and Ed, you can take us into it, and
Sure.
and then I'm sure the students can show us some things about the car and so forth.
Sure. I would introduce it. This is a 1/10 scale model of an actual autonomous car. And we're going to let the students go through some of the components and speak to some of the stuff they learned, but really wanted to emphasize that one of the goals of this program and the philosophy behind it is to really work and introduce collaboration, teamwork, and communication skills, which help with solving these real-world complex problems, engineering problems, and other problems in the world. So, with that, if Gabby or Anthony, if you guys wanted to take a crack at sort of explaining some of the different components of the car.
So Gabby, you want to take it first for us?
Sure. So this is the autonomous car, and it has some different components that help with maneuvering through the different environments that we had to, such as between two walls and over bridges and under it, and then also telling which shade color of a road we had to follow. And so some things that helped us was the LiDAR and then a camera, and those were really helpful in coding and sensing the environment. And then also it can go up to 40 miles an hour, which we had a cap on, so we couldn't go quite so fast. We actually ended up breaking the cap. But and then it's also got a powerful Jetson powering it, and it's kind of like a computer. It is a computer, and it's pretty powerful, and so that helped run the programs that we were writing.
So, to both of you, I mean, what experience did you have coming in with working with such a high technology device?
Well, Anthony and I both were in the robotics program here at Nauset, and then Anthony had taken Python.
Yes, Python in this school system with Mr.
Right.
Susan.
Yeah.
Yes.
So you had Python coming into it.
And that was my really only coding language experience.
And so once we and quite honestly, this is all about the programming of this vehicle, because on August 6th you actually brought it to a race, and so let's define for the viewers what are we talking about here, and let me introduce that. There was it 70 students from all over the world who were
60, 70 students. Yes.
who this was a summer program at MIT for our viewers to understand, and these are students who had applied from all over the world for the opportunity to spend a few weeks at MIT doing the exact same thing in terms of studying this vehicle and getting it programmed for a race on August 6th. The only difference is that we traveled up on August 6th with our vehicles to put them in the race. So what was the race, and what was the object of the race? Anthony, do you want to talk about that?
Yeah, so basically all the students were divided up into 12 teams, and then we had 2 teams out of the students from Nauset, and there was a large course which had walled sections and bridges and underpasses and overpasses, and also a line following section. And we started with time trials where each car autonomously started and had to go around the track the fastest to get a time. And then that time was divided you into various heats, where then 3 or 4 cars would race each other, which finally narrowed the field down to the Grand Prix, which was the final race at the end. And the winner of that race was the winner of the whole thing.
So, Gabby, had you seen the track before? I mean, did they tell you this is what to plan for, or how did that work?
It was about a week or 2 before the Grand Prix race that we had access to what the course would be like, and we used a simulation program that we ran through Linux called Gazebo that they had released a simulation track that we could go through. It wasn't exact of what we would experience at the actual Grand Prix, but it gave us a good idea about what we needed to do and what we needed to accomplish in order to complete the course.
And on that point there, just so people understand, components used to this, it uses a software called the Robot Operating System, which is an open source software used kind of worldwide in academia and in industry in robotics. And if you want to describe your experience, because that was introduced new to both of you, but I think it really tied together how all this comes together. And then the gazebo environment is a simulation of a world. And then there's also packages within the robot operating system that we didn't have a chance to cover in the 4 weeks, but with the hope possibly in the spring with running a 15-week regular day program, we potentially will be able to get into some of what they call the remote vision, where you can actually see what the robot sees on your output. But could you speak a little bit to how it was to work with the robot operating system, and did that kind of tie things together for you, or was that, because it's kind of a different approach to how it runs. It's almost like a little bit of a mini world within itself.
Yeah, so, I mean, robot operating system was completely different from anything I had ever done. And, I've done a lot of stuff with computers on my own, but never anything like this. And to have the experience of working with something like robot operating system that is so much used in the industry beyond just education and outside of education, and maybe is something I might use in an actual job someday. So to learn how all that works and be able to use it was a really interesting experience.
Yeah, I agree with Anthony, and we actually ran ROS through Python, so we kind of wove that in as an import into our programming. And it was actually, I found it really interesting, the application of calculus into programming the car and using ROS, Robot Operating System. And I found that really helpful and cool how math is actually applied and how you can use it.
It's interesting, as your superintendent, to have watched from a distance and understanding, because I was intrigued by the concept of having a project-based learning experience for you. And of course the project would be the autonomous car and your ability to make it do what we needed it to do to be in the race. But along the way, you had to learn some calculus, you had to learn some trig and so forth. And I after reflecting on the experience for you this summer, I was amazed at how many times I've gone into a math class and had students whisper to me, when am I ever going to use this math? And it's just the opposite in this case. In order to find success with this project, you were learning applied math, no matter what the math was, to actually make the project work. And of course being excited because it was all part of the goal to get to the race and make it happen, right? Mm-hmm. So I'm intrigued of the impact of this project and how we move forward with more project-based learning for all kinds of levels of students and interest of students in the future. The interesting piece, of course, is the ability to now break this down so that we can explain it. Not only here tonight on the TV show, but going into the different schools, both the elementary and the middle schools, and demonstrate and introduce using language that a third and fourth grader might understand, so that they could be excited to get involved in projects like this in the future. So, Anthony, you talk about its application in terms of maybe what you want to do in your future. Where do you see that connection for you going forward in your dreams?
Well, I'd really like to be an engineer, and specifically something in the computer field, and some kind of robotics program, as a career has really always appealed to me. And to be able to do this program where I learned, what a job in that field might actually be like, that really helped me decide that that's what I'd really like to do.
And Gabby?
Yeah, kind of echoing what Anthony said, that it helped put things in perspective for me and what I wanted to do. I also would like to go into engineering, preferably maybe aerospace or something along those lines. Yeah. And this really helped kind of show me how many opportunities there are and kind of what I'd be doing in those fields.
So you had the opportunity to go to MIT, and when you mentioned the opportunities, talk about what you took away, because you were on the campus and visited a number of areas. Some of your thoughts on that experience.
It was really cool to go on campus and see what it was like to kind of visit the college and what kind of people are there and what programs there are. And there's a lot of programs that are super cool.
Yeah, it's overwhelming. I had the opportunity to travel with Mr. Romer a couple times up there, and at first you just have to step back and get your bearings in terms of what are we talking about here, right? Anthony?
Yeah, it's just like you always hear, oh, MIT is like this big school, and to actually get to go there and get like the insider tour and see all the buildings and see the classrooms and everything. It's just, I keep using the word experience, but it was just an amazing experience.
One of the aspects that I'd like to say that in conversations with some of the labs and some of the professors at MIT, that they, particularly with race car and these summer programs, is that this really brings together the teamwork and communication, collaborative aspect of what MIT is kind of known for, their hands-on project-based learning, and they talk about ways. Can you talk a little bit to how this it might have been different than a traditional approach of what you've been gone through before this, and also how the teamwork and collaboration and and communication really works to maybe take an abstract concept and really solve a complex real world problem?
Yeah, so it helps answer the question when you're learning something, when am I going to use this? Because when you're in a classroom and there's no project, it is kind of hard to see it sometimes when you're going to use this. But when you're doing project-based learning like we were doing, it's really easy to see exactly when you're going to use this because, you learn it today and tomorrow you need to apply it. So I think that being able to do this project-based learning really gives you a lot more motivation to learn things, and it makes it a lot more fun because you know what you need to use it for.
One of the things that, and for our viewers, this classroom was actually held at the central office, and so they were downstairs in the conference area, and that became their classroom. But in all my visits, what I saw was students helping each other every single time I came in, and every time it seemed to be different groupings of students, and in some cases, students were teaching students that the problem set that you were working on at some point. Some students grasped the concept faster than others, but there was a great deal of cooperation between all of you in terms of trying to pull everybody along and assist with helping. And that one of the pieces in my other part of my life, I have two children and one who's in the tech world, and they all work on teams. And it's amazing as I've watched my children go into the private sector that teams are everything in terms of solving problems or helping each other with a problem set and things like that. So without even knowing it, you experienced that, didn't you, in this classroom? I think one of the pieces that I think you touched base with, Anthony, is how does the school system in the future get more in line with problem sets and project-based learning and having a goal through a project versus, in some cases, we just got to get through the chapter to take the chapter quiz or the test and move on. It's interesting to understand that for some of you learning trig and calculus over the summer at pretty high levels without the typical textbook approach to it, and yet we had some success with it going forward. So Ed.
One of the pieces that I wanted to say that was part of the challenge and the excitement of this, that both the superintendent and I and some of the people from BeaverWorks, the director Bob Shin from BeaverWorks, it made this kind of exciting for us, is we took a cohort of whatever kids came through the door. 8 kids gave up their summer, and they ranged from 9th graders to rising 1 senior and 2 rising seniors here, juniors. So we had a cohort of 9th through 12th where the actual program at MIT was very selective around the country, and some teams from around the world that were all rising seniors from some of the top high schools in the country. And that we put on a really competitive challenge. I think we broke through a barrier to show what the power of project-based learning kind of breaks through some of the pedagogical beliefs that have been around for 50 years that might be challenged. Some of the work at MIT is looking at the latest work in cognitive neuroscience and how people learn, and that was exposed with part of this. So there's a challenge to the conversations we have going forward. But did you find that the introduction, I think you said the introduction of the material, where you'd be presented with material, then you would stop and apply it? And what I understand as a layman with this, I'm not I'm learning a lot from these folks, is that's the new model. That's the teach a little bit and then transfer it from short-term to long-term memory. So,
much of the focus in education is on long-term memory. I mean, it makes no sense to memorize something to simply forget it. And anything that we can drive forward with strategies and approaches that takes it to the long-term memory piece is critical. And it's critical for you going into your engineering field, hopefully, and likewise for you, Gabby. And I know you have a lot of options to consider going forward in this whole big field. The piece of it, of course, is to be able to explain it. And that's what I'm hoping for as we move forward when we go into the all-school meetings in all of our elementary schools. And for us, we hope to continue to work with MIT on a pre-K through 12 curriculum in robotics. That great appropriate work is done, so that it's just not a one-and-done concept. That for students like yourselves, I mean, one of the great challenges I think we have is to continue to challenge you. I mean, this is for our viewers to understand, we were the only public high school to have a team in the United States in this competition, and so we can feel proud that we're standing out amongst our colleagues and our classmates across the United States. But this is just the beginning, right? What was your favorite part of working with a car? I mean, I'll be honest, before you jump in, I'm anxious to see this thing do 48 miles an hour or something. I didn't see that, but what was your favorite part of it?
I think my favorite part of getting to work with the car was probably that the first time we ever got it to actually move under its own power. Because there had been so much buildup and so much talk for so long about programming the car, and then we finally got there, and we had to, drive forward 4 feet and stop, and that was just such a big moment.
Can you ever imagine that would be maybe the highlight of your summer is moving the car 4 feet? Gabby?
Yeah, I think it was just satisfying to work with, especially when things compiled and we got them to actually run on the car. And I also just really enjoyed the whole experience and learning about this technology and kind of just everything. Yeah.
Some nerves on the day of the race?
Yeah.
Can you talk about that feeling?
Well, when we got there, we had some surprises about the course, and so that was pretty nervous, and kind of rushed to learn how to code AR tags and stuff, and that was pretty stressful, and yeah.
And what does that mean? Because I don't know that language.
AR tags there's actually one on the car. It's one of these. So we got the camera to pick up and read these tags, and that would help us switch between our programs, such as for the line follower program to the controller, which would maneuver between the two walls of the course.
And you had to do that day? Did you know that you had to do that?
No.
Not before we got there.
One other piece that's really exciting and coming from this, I know I've talked with both of you, but when we try to offer something in the spring that both Gabby and Anthony have talked about wanting to help assist kids that have no experience with this, and that's one of the really exciting opportunities this presents. And I don't know if you guys want to share a little bit about what you see going forward or ways that we could do more at NASA with this.
Yeah, well, I'd really like, now that I've learned all this information, I'd really like to share some of this with other people. And when we did the course, we had some kids there that were able to help us, some great teachers, and I'd love to take that role in the future and kind of give back what I now know and help other kids learn it.
Gabby?
Yeah, I think it would be really cool to help other people learn what we experienced and share our experiences with them and give them the chance to program this car and learn how we learned.
Sure.
And the instructors we had were really fantastic to help us, help teach us and explain the concepts. So
I've often thought teaching students is the best model. And so I know that Mr. Romer is very, very interested in expanding the opportunities for other high school students to begin to learn some of what you were taught over the summer. And you've already heard me speak about how we want to go into the elementary schools and do some demonstrations. Because I can tell you right now that the young students seeing this vehicle actually move on its own, they'll go crazy. They'll be so excited and want to know more. And I think the other piece of it is that we're going to be working with your other classmates who aren't here today, and we hope to do a series of shows here about this project. So it's not going to go away, and we hope to build on to that in the months to come.
What would you see in closing, you think, the interest of kids that don't know about this, and what kind of, do you think this would open up opportunities and possibilities to things that kids to excite them about science and engineering and possibly make math come alive?
Yeah, I mean, it even got me excited, and I was already excited before we started, and it only got me more excited.
Okay.
So I think it definitely has the possibility to do that.
All right.
yeah.
So it seems to me that maybe we should start with a big demonstration of this right here on this campus. And because I've already heard that a number of you have friends who also have the passion you have, who are thinking about how can they get involved and learn more. And we're planning for another summer program already for next year. So I think getting the word out and working with the administration to get some time to maybe go into Fieldhouse and see this thing do some of its abilities would be great. Right. So I'm sorry to tell you we're out of time, but I want to say a couple of things. I want to tell you how proud I am of the two of you and your classmates, and they're probably going to come on the show at some point as well, because you gave within 3 days. You gave up your summer for a passion that you knew very little about. And you brought great success to both yourselves and your families, our school, and our community by participating in this project at MIT. And to Ed, I want to thank you and Harry for volunteering your whole summer.
Thank you.
To give our kids that opportunity.
Pleasure to.
So to our viewers, I hope you've got some insight into this great autonomous car and these great students. Thank you, and good night.